please give a warm welcome to our next speaker from TU München, Gordon Cheng.
Thank you, Sarah. Okay, I know you're all tired. I'm going to ask you another question. How many people remember what happened in 2014? 8 years ago. It's not that long. And most of you are not that young. Can you remember 2014? Come on. I think you thought I was going to give a robot talk. But I'm going to start with a soccer talk. Okay, 2014, Germany won World Cups, right? And we never talk about 2018, of course. Right? It was a great event. It was a fantastic event. And the thing was that I was at the beginning of this. I want to share with you some of those moments. Right? Why I wanted to share with you this moment. And in 2014, when the game opened, right, before the game opening, a friend of mine came to Munich and then said, I challenge you, build an exoskeleton to make somebody walk again. And the person, and then they said, the challenge goes on, right? Please, right, I never want to work with FIFA again, but do the opening kickoff for the FIFA World Cup 2014. So this is Giuliano Pinto. Right? And he made the first kickoff of the World Cup, 2014. He made the whole thing happen. Okay? So the challenge was, how do I actually get him to actually understand, right? Because he's completely from trunk down. He's paralyzed. Right? We ended up with 8 patients training for this event, right? And they were completely paralyzed from the trunk down. Okay? One of the most key ingredient that I was challenged to do was that restore the sense of feeling. Every time you will take it for granted, or I will make you don't take it for granted from now on. Every time you take a step from now on, you're actually feeling the ground. Right? If these people are inside exoskeleton, they do not feel anything. Right? And the challenge was restore the sense of touch, right? And this is very critical. And we all know about sense of touch, right? This is something we all take for granted. We can see, we can hear, we can, right? If we lose sense of sight, we can still live. If we lose the sense of hearing, we can still live. If you lose the sense of touch, life is very short, okay? So the sense of touch is really amazing. We do a whole body interaction, right? And I love giving the social interaction. And the social thing is giving my daughter a hug, right, when I see her. And we make contact with the world through sense of touch. Right? And if you think about it, how many robots on this planet have a sense of touch? Right? Virtually none. Right? They don't really have that true sense of touch that we do. Right? We sense every time we somebody's next to us, right? Even in this proximity, you feel your surrounding through this sense of touch. It's very critical, and since it is partially a business event, the application of it is phenomenal. The domain of this, right? You can use the sense of touch for robots, for any kind of things. Entertainment, healthcare is something my heart is in. I want to help a lot of people. Even sports, you need the sense of touch. And, of course, robots. That's why I thought Cobot, the next generation of robot, Cobot, should embrace a sense of touch. Just some basic introduction to the sense of touch. This is biology. I have many hats when I'm a professor and I do many things. I do a lot of technology, but I also I love neuroscience. I love how the brain works, right? So we have actually a modality of sense of touch. We feel temperature, we feel proximity, we feel vibration, right? and we even feel pressure, but we even actually feel the sense of touch before we even touch an object. Right? This is something very important for us to interact with the world. So about 10 years ago, when somebody said, what will you do first when you come to Germany? I said, skin. Right? Nobody understood why, right? Because it was hard. Right? Because I've seen many people tried for the past 30, 40 years in robotics. They all failed. Right? And a sense of touch is not just about, something is on, something is off. Right? That has been the entire domain of robotics so far. So we started building these, right? Being stubborn, I couldn't buy anything, so we started building. Right? We feel before we actually sense before we touch. We feel vibration, and we feel temperature. Imagine controlling an industrial robot arm by just blowing on it. Okay? So you can actually change the way you interact with the robot through a sense of touch. Right? And you no longer be fear of robot, instead of having a fence of robot. But the difficulty with a sense of touch is that on our body, okay, this is more educational, there is at least 5 million receptors on our body to tell us how we're feeling, what is the temperature of the room, are we touching, are we sitting on the chair properly, right? It's all a sense of touch. Right? And it is an entire network of sensors, right? And you have to ask the question, how does the brain deal with this? And why have it failed in the past in all the robotic attempt at putting a sense of touch on the robot? So you have to look at these networks, right? Each skin sensor, right, has to be flexible. Our skin stretches, right? And it conforms to our body, the rest of our body. And what is interesting is when we actually connect all the sensors together, right, it needs to be very, very robust. Okay? This is a hammer test. All right? And this is something we do in the lab to actually show that it is robust enough. All right? And I hate to say this to the IKEA, the table did not survive, but the skin did with the hammer. Right? You can cut it, and it will reconfigure, right? And then you can actually smash it, and then the entire network have to survive. And this is very similar to our body, taking inspiration from biology. This is smashing it, and then you see the whole network recover within 40 milliseconds. Okay. So, where are all these receptors on our body, right? If you look at the engineer around in the room, right, they will say they will calibrate every single sensor at X, Y, Z on every single dot, right? And this is impossible. And our brain do not do that. Our brain do this automatically, right? Inside the fetus of our mom, we start learning about the shape of our body. And this is what we want to embrace, the same concept onto the robot to deploy artificial skin. This is a construction of the entire surface of a cylinder, and instantaneous reconstruction. That means you can actually localize the sensor cell on the body. Okay. Another lesson is that how do you think your body actually deal with how do you respond to every single sensor? 5 million receptors. How do we control our body with it? Inside our brain, we have this phenomenon called motor bubbling. Is one phenomenon, and the other one is stretching. When you're tired, you start stretching. You're actually calibrating your body with your actual sense of perception of your body, and you get the robot to jiggle, and then it start responding. That's the concept, stretch, and it will automatically learn how to deal with the whole sensor and action. Okay, so how can we apply this, right? So I said, okay, I said the challenge is I take any robotic arm in industry and put skin on it and make them safe and interactive. And this is one example of it. We cover the whole body, let the robot jiggle, stretch, right? And it work out where all the sensor is and how to behave. And this is a feather test, okay? Would you believe we let children play with our industrial robot arm? Okay, so the children is given a feather and they can actually control a giant robot arm, right? So that makes the whole thing very safe and interactive. And it's not really a new sense that we know. It's a new sense for the robot that needs it to actually be a main us. So I love challenges. Everybody always throws challenges at me. They say, okay, can you do it autonomously? And can you do it for the human body? Okay, I said, okay, let's try it on the humanoid robot. Right? This is a humanoid robot. It's very difficult to do. And one of the most difficult things, remember I said on the human body, there's 5 million receptors. Imagine how you do that in engineering. In engineering, what you do is you poll. You ask every single sensor, what are you doing? Right? Give me your data, give me your data. Right? That is insane. Our brain will collapse. Think about it. Right? It will not work. Right? How do you handle all the data? Okay? Here's the animation that I said that if we were to do this, right, to put the entire human body, cover the human body, right, that is more than a square meter of skin sensor, right, and up to about 5 million receptors. If you were to do this with classical engineering method, you will need the computer of the size of this hall, right? It is an impossible task, right? Okay, I said the challenge is, let's make it autonomous. Right? Let's put everything onto the body and have the whole body deal with it. Okay, so this is a humanoid robot. We decided to cover the whole thing. Right? It's the only humanoid robot in the world with artificial skin on it, and it's completely autonomous. I say autonomy because this satisfies the challenge. And I do not require entire room for a computer to actually deal with this. It can handle all the balancing by itself, push it around. And there's something in our body that helps us actually detect the sense of touch to help you balance. Right? And the skin is one of the most critical parts. And the other thing that we want to do is deal with walking. Imagine walking on a plane that you cannot sense properly, right, the ground. And this is what happened. On the right, you see the normal standard approach. You will fall. If you do the standard engineering method, you will fall. If you have skin, you will adapt the entire situation to actually walk and carefully select. And one of the hardest things is when you go hiking, pebble. If you have pebble and you can't sense it, you'll definitely fall. This is putting a pebble on the ground. Standard method will actually collapse. And remember the beginning of my talk. Some of the most important things about being safe is, giving somebody a hug. And I would not like my daughter to be inside this robot being squashed without having a sense of touch. Okay, so these are just demonstration of how the facilitation of skin can actually improve substantially robotic in the future. Okay, so the robots are coming, and I'm going to end with an announcement. I've been asked all the time, can I have it? Can I have the artificial skin? Give it, all of the industry, everybody is asking, all the research lab. So as of the next couple of months, we're launching In Touch Robotic, right? And I want to get this technology out of my lab. Right? I love them, but I want to get them out of my lab and then into the hand of others. Right? And I had a lot of fun with them. right, of the technology. Now I want other people to have more fun with it. Okay, so that's the announcement, and I'm going to finish on time. I thank you for listening, and I wish you a nice day.